Hello, everyone. In this video, we will analyze the complexity of several well-known algorithms: binary search, selection sort, and the Tower of Hanoi. Look at the binary search. The binary search is to search a key in a sorted array. Each iteration in the algorithm contains a fixed number of aberrations. So look, this is the animation, and please use this animation to study binary search. And the list is already sorted, and we'll see if the key 24 is in the list. And you compare 24 with the middle one, if it's less, and now you are going to search only the first half. If it's great, and then the search is reduced to the second half. So this is what happens. You're going to reduce the search area by half. Let Tn denote the time complexity for a binary search of a list of n elements. Compare the middle element with the key. So this is to determine when you go to narrow your search to the first half or the second half, that is time is constant, is C. And now the problem is reduced to the same problem to perform binary search in the half the size of the previous one. And then continue to reduce it, and that's what you see all the way down. Every time the size is reduced by half. So this is K, and now how many times you perform this constant comparison? It is K times. What's the K? K is log n. So the overall time for binary search is order of log n. Now let's look at the selection sort. Selection sort is to select the smallest element in the list and swap it with the first one, and then continue to do it for the remaining list. Select the smallest one and swap with the first one. And this is how this works. And the time complexity, we're going to use this Tn to denote it. So Tn, the first time, is the list of the size of n. So the time to find the smallest one, it is n minus 1 times comparison. And this is the constant time to perform the swap. And then you have the time. The size is reduced to n minus 1. So pick the smallest element in the remaining n minus 1 elements is n minus 2 time comparison, and then plus C. So you can see the overall time is this, add all this together, and this is the n squared divided by 2. That is the dominating part. So this is the dominating part. Ignore the smallest part, the non-dominating part, and the constants. So we get this, the time is order of n squared for selection sort. Now let's look at the PowerHanoi algorithm. So this is what we do for the PowerHanoi using recursion. We're going to move the disks. Total is n disks from A to B with the help of C. So what we do is first we're going to move n minus 1 disks from A to C with the help of B. and then move disk n from A to B. After this, we're going to recursively move n-1 disks from C to B with the help of tau A. So the complexity, let's use Tn denote the complexity for the algorithm that moves disks. And C denote the constant time to move one disk. If there's only one disk, so that's T1 is C. So look, this Tn is reduced to Tn-1 plus C and Tn-1. So this is 2 times Tn-1 and continue to expand it, Eventually, this is what you get. Add all this together, and this is C times here 2n-1. And ignore and the constant and the non-dominating part, we get this order of n 2n. Now, this is the n is exponent here, 2n. This is called exponential time. So when you increase n, your time complexity, you increase n just by 1, the time complexity is doubled. And so this is a very inefficient. It's exponential time growth. So it's a very, very slow algorithm for this order of 2n. Now, these are the common recurrence relations. And we have already encountered some, and we will use others in the future examples. And here is the recurrence relationship. If you have this Tn, the time complexity for the input is n, it's reduced to the half, okay, and plus a constant time. And so the overall time is going to be order of log n. Like binary search, and in the future we'll look at the Euclid's GCD algorithm. It is order of log n time. So this is, if you have this problem and reduce Tn-1 and with a constant time here, and this will eventually, it's a linear time. So please, and look at this and keep in mind, and we will use this in the future. This is the summary of all this common time complexity. Order of 1, it's a constant time. Order of log n, it's logarithmic time. Order of n is linear time. Order of n times log n, that's a log linear time. Order of n squared, quadratic time. Order of n cubed is the cubic time. Order of 2n, this is the exponential time. You can look at this graphing here. So look at the time here. This is the constant time. It doesn't change when you change the input size. And this is the logarithmic time. It grows, but really slow. So if you have this is the input size doubled, you only grow by 1. And the linear time, it is this. And this is the log linear time. So n times log n. And now you see this is the exponential. When n grows, it goes so fast. That's all for this video. Thank you for watching. See you on the next video.